This section I'm going to throw in, even though it's not a section from your textbook, it is a section that was in the old book that I still feel is important and needs to be taught. So we're going to start with this. What I want you to do in a second here is pause the video and try the front yourself. We won't go over this till tomorrow, and I expect you to have the front 6 done. It is a skill that you need to develop, being able to recognize a function in its derivative, in the derivative from a picture. And if you don't take the time to think yourself through it, it's not going to be a skill that you acquire. So pause the video, do the front side of the notes. All right, now that the front side is complete, let's skip over to the back side of these notes and find some derivatives. So f prime of t, this shouldn't be tricky for you anymore. 8t to the 7th minus 42t to the 5th plus 8t cubed would be the derivative. And to derive again, 56t to the 6th minus 210t to the 4th plus 24t squared. Simple derivatives. You might have some derivatives today that require the chain rule or product rule or quotient rule, but derived just like always. Here's another one. If we think of this as r to the 1/2 plus r to the 1/3, might be a little easier. First derivative, 1/2 r to the negative 1/2 plus 1/3 r to the negative 2/3. I'll let you leave them negative exponents this time, just so you get the gist of what's going on. So, second derivative, negative 1/4 r to the negative 3/2 minus 2/9 r to the negative 5/3. Now, we talked a little bit about this in the previous video. If s of t is the position function or the distance of a particle, then f prime of t is the velocity. Its label would be meters per second. The second derivative we talked about in one of our examples yesterday also, although you didn't know it yet, is the acceleration. And it is meters per second squared, because it's meters per second per second. And finally, the third derivative is rate of change of acceleration, which does have a name, sometimes known as the jerk. So if you want to insult someone without them knowing, you can call them a third derivative. And its label would be meters per second cubed. So, find and label the velocity and acceleration. Velocity is the first derivative, so we get 6t squared minus 14t plus 4. Acceleration is the derivative of the velocity, so we get 12t minus 14. Part B, find the acceleration after 1 second. Well, the acceleration after 1 second is what we get when we plug 1 into the acceleration, which is negative 2 meters per second squared. Make sure you're labeling things if you know the labels. Finally, find the acceleration when the velocity is 0. Well, in order to do that, we need to figure out when the velocity is 0. So when is v of t, which is 6t squared, minus 14t plus 4 equal to 0. We need to factor. Pull out that 2 first. Always pull out your GCF as your first step of factoring. This factors into 3t minus 1 and t minus 2. If you are not good at factoring, come see me. We need to have a little meeting and review a little bit, possibly catch you up. But factoring should be something that at this point you have no problem doing. So 3t minus 1 equals 0, t minus 2 equals 0, so t equals 2, and t equals 1/3. And they want to know the acceleration at those times. The acceleration at 2 is 12 12 times 2 minus 14, which is equal to 10 meters per second squared. And the acceleration at 1/3 is 12 times 1/3 minus 14, which is 4 minus 14, or negative 10 meters per second squared. Negative 10 meters per second squared. So, look this over. Questions, come with them tomorrow.